So what we're going to do is work in the opposite direction. So in the previous videos, we were given cutoff values and finding probabilities. Now what we're going to do is be given probabilities or percentages. A common word used for this is the word percentile. If you're given a certain percentile, it's always area to the left. So in the image to the right-hand side there, where it's a bell-shaped curve, and you have 70% to the left-hand side and 30% to the right-hand side, this would be a graph showing the 70th percentile. And what we have is this value that's basically the cutoff for the 70th percentile. Now these cutoff values, that term is mostly describing an x value. It's like an actual value for x related in terms of the context of the question with some mean, some standard deviation, and where is that cutoff that's dividing up these percentages. A little kind of step in the middle there is that we need to find the critical value. If you see the term critical value, that relates to z-score. It's really saying find the z-score associated with that cutoff value. So we're going to be finding these critical values first and then changing it to our cutoff value, which will be related to our question. So let's go back to our rainfall data. Again, we have that mean of 40 and standard deviation of 8. And with these questions, they're telling us about a percentage. So we're going to look at these three cases. We're going to have this lowest 10%, highest 5%, and this middle 50%. And what we want to find is what's the rainfall that's this cutoff for the lowest 10% or highest 5%. Or in the case of the middle 50%, we'll have two cutoff values. So visually what this will look like, looking for the lowest 10%, we're going to have some sort of division on this left-hand side, because lowest 10% will look like this small area to the left-hand side on our bell-shaped curve. And this area to the left of 10%, we would also call that the 10th percentile. For highest 5%, if we're on the high end, we'll be on the right-hand side of our curve, and highest 5% will look for this area to the right, and so they'll be describing this area to the right of 5%. Now in terms of percentile, which again, we're going to be using our z-table here, which is all in terms of area to the left. So what we'll need to think about is if we know the area to the right is 5%, then we know the area to the left is 95%. So if it's highest 5%, it's also 95th percentile. Then middle 50%, just like with how we use the z-table to find values find the probability between two values, this is also going to be kind of tricky with a little extra work there. But what we want is kind of this symmetric division of our table so that in between two values, we'll have 50%. So we'll talk about how to do that one once we see these kind of simpler cases up above here. So in these cases, we know the percentage, which means in terms of our table, we know what's going on in the middle. We know what value's coming out in this part of the table in the middle, and we need to find the z-score, or in the term you'll see popping up is critical value. So we're going to go searching for our areas in the middle of the table and then find the corresponding z-score. So with this first case, they tell us that we have this area to the left. So we have this lowest 10%. And on the table, how that would show up is 0.1000. So what we're going to do is go searching on our table. Now, a nice starting off point, like looking at our picture that we drew, if it's the lowest 10%, our z-score is going to be negative. It's on the left-hand side. We still always have 0 in the middle there. So with that, I know which part of the table to look at. And then we just go searching. So we go to our table, and I'm just going to start searching for 0.1 and then followed by a bunch of zeros. Now, most often, you won't find the exact value. So what I can see is if I'm looking for my 0.1 and then I get closer with a 0.10, so I'm kind of tracking here, like there's 11.51%, 11.31%. It's getting smaller and smaller and smaller, and now I'm in my 10%. And then I get to this spot right here with the 0.1003 and the 0.0985. Somewhere between those two is the value that I want. 0.1000 is between those. So when it's in between, what you want to do is think, which is it closer to? And that's the value that we'll use. Now what you could do is use subtraction and see. So like if I take 0.1000 and subtract it with 0.1003, I can see that it's only off by 0.0003. Whereas if I do the other one, it's going to be a larger area. If I take my 0.1000 minus 0.0985, well, I can see that's a 0.0015. So if you kind of ignore the first two zeros, it's like comparing a 3 with a 15. And so with that, this value of 0.1003 is closer. So when you land in between, try to figure out which value is closer. In the next one, we'll see an example where they're kind of equidistant. And so we'll talk about what to do when it's perfectly in the middle. But use some subtraction to see which is closer first. So where this is lining up is we have a negative 1.2. matching up with the last digit of an 8. So for our critical score, our critical value, it's a negative 1.28. So we get our critical score. But now, in terms of rainfall, I still don't really know where I'm at because I want to know what's this cutoff for the lowest 10% of rainfall. And negative 1.28 doesn't translate directly to answer that. So this is where we need to change our z-score into something that matches up with, in this case, the context of rainfall. So to do that, we need to go back to our z-score formula. So remember, z is taking our x value minus the mean over standard deviation. And now what's going to happen with these questions is we'll have all of the information except for our x value. And it's our x value, that's our actual cutoff value that we want to find. So we'll have to do a little bit of algebra here. So what we're going to do is plug in. We'll have negative 1.28 is our z-score, and then equals our unknown value for x, minus the mean of 40, all being divided by 8. So we have this set up where we have all the information except for x, and then we solve. So the process for these, first thing you'll do is multiply both sides by the standard deviation, which in this case is 8. So that would give us a negative 10.24 on the left-hand side. And then when we multiply by 8, that cancels out the denominator, so all we'll have is x minus 40. And then add the mean to both sides. And that gives us an x value of 29.76. So in terms of the cutoff for the lowest 10% of rainfall, that'd be 29.76 inches would be the cutoff for that lowest 10%. So that's the process for these. First thing you'll do is figure out your area to the left, look that up on the table and find the closest z-score, and then use that z-score formula to solve for x. So let's try that out with this next example with the highest 5%. So highest 5% will relate to 95th percentile, and really it's that 95% that we want to use because that's area to the left. So when we go to the table, we want to find an area to the left of 0.9500. So let's go to our table and go searching for a 0.95. Now, looking around here, I just start tracking, and let's see, it looks like it'll be right between those two values there. So between those is 0.9500. Now, looking between those two, what I can see is if I use subtraction, it's going to have the same difference. They're going to be equidistant from each other. So what I have is this kind of competition between two z-scores. It's like that first one is this 1.64 that's making that 0.9495, and it's competing with the 1.65 with that 0.9505. So since it's exactly between them, we're just going to take the average of those two. Average them out so that we can get the middle value. So with it being perfectly balanced between the two, we'll just take 1.64 and add that with the 1.65 and cut it in half just to average them. So we want to use this z-score of 1.645. So just grabbing a z-score that's exactly halfway between them. And that'll give us the best accuracy here. So we'll use that for our formula, taking 1.645 equal to, we don't know what the actual cutoff value is, minus the mean divided by standard deviation, and then we solve. So multiply both sides by 8, and that'll give us a 13.16 equals x minus 40. Add 40 to both sides. So that'll be a 53.16 inches of rainfall for that 95th percentile, or that highest 5%. So if the z-score lands right in between, average the two. Otherwise, like in the first example, just figure out which one's closest. All right, and then this last one that we're going to look at for middle 50%, we're going to have two values that we want. We want this first cutoff value and the second cutoff value. So we'll need to find two things. And thinking about area to the left, x1 has an area to the left of 25%, right? If we have 50% in the middle, that means we'll have 25% and 25%. So for x1, we want to find area to the left of 0.2500, or sorry, of 0.25. That's going to be the actual area. And then for our second value, the area to the left is going to be, and we'll take that 50% plus 25%, so that would be a 75. So we'll go searching for those two z-scores that we need. So we'll have some z-score for x1 and then some z-score for x2. So let's find that 25 first. So again, we're in the middle of our table here and just going to search around for a 0.25. So here I can start to see my 0.2s, and then I just want to get as close as possible, and it looks like right here I'm between two values. In between there is my 0.2500. And then what you could do is just use some subtraction to see which is closer. In this case, it should be the 0.2514 is closest. So with that, we're going to be using a z-score of negative 0.6 with a second digit of 7. So that first z-score is a negative 0.67. Now, with z-scores and using symmetry here, what we'll end up having is a positive and negative version of the same z-score. And we'll still look it up, I'll show you this, but in terms of having 0 in the middle here, and then we just found that's negative 0.67, if it's symmetric, that's going to be a positive 0.67. So you can either just use the symmetry and be done with it, but just in case and just to get some extra practice with our table, what we'd be doing is going to find that 0.75, get rid of those, and let's see, 0.75 is up higher here, and let's see, we're going to be between this 0.7486 and 0.717, and when you do any calculations, you'll find that 0.7486 is closest, and that shows us our positive 0.6 matching up with the 7, so we get the same z-score out. So when you have these cases of like middle percentage, you'll have symmetry of your z-scores of positive and negative. So then what we want to do is change these in terms of being in rainfall. So we could do is find our negative 0.67 and then equal to an x minus 40 over 8. Multiply both sides by 8. So we'll have a negative 5.36 equals x minus 40. Add 40 to both sides for 34.64. Then we'll do the same thing for the positive 0.67. Multiply both sides by 8. Add 40 to both sides. And that's it for that middle 50% of rainfall. That's going to be between 34.64 and 45.36 inches of rainfall. So with these cases where we reverse the order, you'll have your percentage to the left. Search in the middle of the table for finding that percentage, get your z-score, and then translate it into an x value using the formula for z-scores.